Good morning or good evening, depending on what time you are watching this video. This is Mrs. Lyons, and this video is going to go over some stoichiometry using thermochem. All right, so let's see if we can get adjusted a little bit. There we go. Okay, so we've talked about stoichiometry, we've talked about limiting reactant, we've talked about just general mole conversions. Now we're going to take that and apply it to energy. Okay, so as we've been talking about, the change in energy, in enthalpy, delta H, is what we have been talking about for this whole unit. Okay, for us, we're going to look at energy in the terms of kilojoules. So we'll abbreviate that KJ. Okay. It turns out that we can calculate the energy change in a reaction specifically using the mole ratio and the balanced chemical equation. Okay, so what we're going to do is we're going to kind of modify our mole map a little bit. So basically, we are going to, with the calculations we do today, we're going to be able to convert between grams and moles. Okay, we've been able to do that for quite some time. And then we're going to be able to convert between moles and energy, or kilojoules. Okay, just like always, we're going to use the molar mass here. And here, moles to energy, we're going to use our balanced chemical equation. And we're going to kind of combine mole ratio and our change in enthalpy. Okay, so let me show you how that works. Okay, so the first question says, how much heat, so we're looking for heat, will be released? Okay, the fact that this is being released tells us that this is an exothermic reaction and that our delta H is going to be negative. Okay, all right, will be released when 6.44 grams of sulfur dioxide, so sulfur dioxide is this one, all right, when 644 grams of sulfur dioxide reacts with excess oxygen to produce sulfur dioxide. Okay, all of this is extra information. We're looking for heat, and we're starting with grams of sulfur dioxide. So I'm going to put this up here, 6.44 grams of SO2. Okay. To get our first step, we have to go from grams to moles using the molar mass. Okay, so we're going to say 1 mole of SO2 is equal to how many grams of SO2? So here we have to calculate our molar mass from our periodic table. So sulfur is 32.07, oxygen is 16, and we have 2 oxygens. So if we add all of this together, we should get, let's see, 12, 13, 14, 64.07 grams. Okay. So our grams are canceling out. Now we have how many moles of sulfur dioxide is produced. We want to go all the way to energy. So to do that, we're going to use our balanced chemical equation. Okay, so we have 2 moles of SO2. And for every 2 moles of SO2 produced, 792 kilojoules of energy will be released. So minus 792 kilojoules. Okay, so let's calculate this. All right, so I've got 6.44 divided by 64.07 times negative 792 divided by 2. And I get negative 39.80. negative 39.80 kilojoules. Okay, since that's negative, as we said earlier, energy is being released. That's an exothermic reaction. All right, let's try a second example. How many grams, so we're looking for grams, of sulfur trioxide, so now we're talking about this sulfur trioxide, would need to react in order to generate 23.34 kilojoules. Now, generate also means produce. Okay, so we're looking at a negative. We want to know how much energy it's going to take to produce 23.34 kilojoules. And that's negative because this equation's exothermic. All right. So we're going backwards in our if we're looking at our mole map, we're starting with energy. We're going to go to moles and then to grams. Okay. So in this case, I want kilojoules on the bottom. So my kilojoules is still minus 792. Okay. But I'm looking at sulfur trioxide. So every 2 moles of sulfur trioxide produced results in minus 792 kilojoules of energy being released. Okay. And then we need to get to grams. Okay. So we're going to use our molar mass. We know that 1 mole of SO3 is going to be equal to the molar mass of SO3 from the balanced equation from the periodic table. So if SO2 is 64.07, I just need to add another oxygen. So that gives me 80.07 grams of SO3. Okay, so let's calculate. Negative 23.34 times 2 times 80.07 divided by a negative 792 is 4.72. Okay, I'm going to check my math one more time. It's always good to check your math. Times 2 divided by negative 792 times 80.07. Perfect. Okay, now this is grams of SO3. So something to pay attention to, okay? When we're doing these reactions, especially the exothermic ones where we're talking about energy being released, when we're calculating from energy to grams, we should have 2 negative signs in our math because we can't have a negative number of grams. Okay, so when you're doing these calculations, keep that in mind. If you're converting to grams or moles, that has to be a positive number. Okay, let's do one more example. If 10.5 grams of oxygen is reacted, how much heat would be produced? I'm going to write my equation back down here. So I've got 2 sulfur dioxide plus O2 produces 2 sulfur trioxide, and my delta H is negative 792 kilojoules. And again, I can go from grams to moles to energy in joules or kilojoules. All right, so let's do this one. So we're starting with 10.5 grams of oxygen. We want to know how much heat would be produced. Okay, so 10.5 grams. Now, when this says oxygen or any element or compound, make sure you're looking at your balanced chemical equation and picking out the right formula. Okay, one of the biggest mistakes I see is when someone reads oxygen and they just calculate 1 oxygen. Okay, since oxygen is one of our diatomic elements, we need to have O2, and that's the way it is in the balanced chemical equation. Okay, so just keep that in mind. All right, so then we're going to go from grams to moles. Okay, so we know that the molar mass of oxygen is 16. We pretty much all know that now, right? And we have 2 of them, so that's going to be 32 grams of O2 is equal to 1 mole of O2. All right. And then if we look at our balanced chemical equation to get to energy, 1 mole of O2, because there's no coefficient there, for every mole of oxygen reacted, we produce 792 kilojoules of energy. Okay. All right, so let's do the math. 10.5 divided by 32 times negative 792. We end up with minus 259.88. Minus 259.88 kilojoules. Okay, so hopefully we've just added a little bit to our dimensional analysis, and hopefully that makes sense. It doesn't cause you too much confusion. So you can do some practice, and I will see you in class. Take care.